This video will look at how to generate random numbers. So I have a beginning of a file here, compile and execute that, and we see the output. So before we dive into this, I want to show where the official documentation is. Right? You do a search on Java documentation, and the particular version of Java used on Codio is 11. Let's go to 11. And you want to look for a link that goes to the Oracle website. Oracle is a database company that owns the copyright on Java. So Java documentation home. Now, there's a lot going on here. What you specifically want to look for under specifications is API documentation. You get all these things. The very first one, Java Base, right, is what we're going to be using mostly. And if you skim down here, right, you'll see java.util, java.util, which is the library that you've been importing to create scanners. This shows you the details of everything else that's in that library. Interfaces we'll get to a little bit later in the course. Class summary are the utility classes that are available when you import that. And they're in alphabetical order. You see there's scanner. If you click on scanner, it gives you the official documentation on how it works. Constructor summary. There's the methods. And again, these are in alphabetical order too, and you see things that you're already familiar with. Next. So the second column here, where it says next, next double, next int, next line, methods that we've been using. Right. On the left is the return value that method yields. All right. So next int gives you back an int. Next line gives you a string. Next, without anything, gives you a string. Another utility class of interest to us, particularly in this video, is the random class. And you click on that. There's how you can create a new one. We're going to mostly use this top one. The one that takes the constructor that takes a seed is used if you need reproducibility. And if you scroll down here, there's some of the same things. Next float, next double, next int, another version of next int that takes an argument, and you see in the same return values. Right? Next int returns an int, next float returns a float, and so forth. Next boolean returns a boolean. But there's no input associated with these. So it's the same methods, or some of the same method names, but execution doesn't stop and wait for you to enter something. It just makes up a number. Now, let's see how that works. All right, so this import statement is good for scanners and random objects, but you still have to create it. You create it like this. The class name random, and then any identifier that will help you remember that this is a random generator. I'll call this my random gen. And that equals a new random just with empty parentheses. So unlike when you're creating a scanner, you won't put anything ordinarily in these parentheses. All right, so this creates an object now that I can use to invoke these methods, right, and get random numbers. So we have to set up a statement. Right, if I just say my random generator, let's try next int. It's an easy one to start with. Dot next int. A value will be generated, but it's not being saved anywhere. I'm not doing anything with it. So this will compile and run, but I don't see the number. If you want to do so, and you almost always want to do something with the number, you have to declare a variable to receive it, because the method call is a right-hand side expression. So this generates a value. This makes up some number. And now you want to do something with it. You save it in a variable. So let's just take a look at it. Recompile. Re-execute. Oh, num is, wow, num is this 3, 6, 9, 10. Num is this 10-digit number. It's over 2 billion. What happens if I just run it again? So I'm going to run it again without recompiling. That means the same program is executing. Oh, it's a different number. Not quite as many digits. About 693 million. Oh, wow, this time's a negative number. This time's a negative number. So next int, if you look back at the documentation, it says that, okay, returns a next pseudo-random. That's because if you generate enough numbers, they'll repeat, but you have to generate a lot of them. Uniformly distributed from the random numbers generator sequence. Okay, so what you're going to get here is a wide range of values. All right, that'll range between about 2 billion to negative 2 billion. Let's try generating a few at once. All right, so I'm going to generate several of these. We recompile and run that. And every time you run it, you'll see 4 different numbers along that range, from about negative 2 billion to positive 2 billion. All right, so another method that you'll actually probably use more often is this next one here, next int with a bound. All right, so the bound works like this. Let's just do the same 4 numbers again. I'll reuse these variables. So if I reuse the variable, I don't have to declare it. You only have to declare it the first time you use it. So I'm just going to put different numbers in here, but I'm going to put a bound. And make a variable for the bound. Int bound equals 10. Bound, 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 bound. You could also put a literal value in there, but that's poor practice. All right, it's better to put literal values in a variable and then use the variable. So I want to see these now, so I'm going to copy this block. And we'll add a little explanation here about what's going on. But this time now, there's a bound of, and we'll say what the bound is, bound of bound. All right, let's recompile and clear and rerun. There we go. Okay, so with no bound, you get the really wide range of numbers. With a bound, you will get a much narrower range. Okay, so the bound, and it says here in the thing, the value will be between 0 inclusive and the specified value exclusive. What does that mean? That means that for this bound, means a bound of 10, that means the result can be from 0 to 9. Okay, well, in fact, that is 10 different numbers. If I count 0, 1 through 9 obviously is 9 values. 0 then is also 1. So if the bound will yield that many different possibilities, but they'll start at 0 and go to 1 minus the bound. Let's try that again. Let's generate some more numbers. Okay, clear, recompile that. Re-execute. Okay, so see that we can get 0. Right? Sometimes you can get the same number twice, which is a way this is supposed to work. So you're not guaranteed that you'll always get a different number. All right, you see that here. All right, in the first round here, you see 6 is generated twice, 7 is generated twice. What you're never going to see is 10. You may see 9, you see 9, you see 0, but you won't ever get a 10. Suppose you want values in a range, right, that don't start at 0. Suppose I want numbers from 1 to 10 instead of 0 to 9. One way to do that is to set up a minimum. So my minimum is 1. My maximum is 10. And now I can compute how many different numbers that is inclusive. So I want I have a range, and the range is max minus min plus 1. So this really becomes my bound now. I can use that as an argument. And copy out this. All right, so you do the arithmetic here. You'll say, okay, range actually is 10. All right, 10 minus 1 is 9, plus 1 is 10. So right now I haven't really changed anything. I'm just using a different variable. Right? So if you want the numbers to start other than 0, you have to add something to the expression outside the parentheses. Okay, and the output is a little jammed together. Let's blank line there. And there we go, generating from 1 to 10. Okay, so we didn't hit a 10 this time, but you're not going to see any zeros. Now, there's a 10. So now we can get 10s, but we won't get zeros. And it is entirely different every time you run it. Now, suppose I wanted to generate numbers from 10 to 20. So I make 10 my minimum, 20 my maximum, and that is 11 different numbers. All right, so 20 minus 10 is 10, plus 1 is 11. But that is 11 different numbers. If I count the 10 and the 20, 11 possible results. So this is 11. Next int range 11 gives me a number from 0 to 10 from here. But if I add the minimum, right, that's going to make this 10 to 20. So that's how you get the range that you're actually interested in. So you calculate the range from the endpoints of whatever it is you're interested in. Add 1 so that it's inclusive, and then add the minimum right after the method call. Notice that the plus min is outside of the parentheses here. Okay, generating now from 10 to 20, okay, 18, 11, so forth. So, and I should be able to get 10 and 20.